Welcome back, everyone. Today we will be continuing with our overview on word problems, this time focusing on some general strategies. Once again, word problems can come in many different forms, so there is no universal method of solving them, but we can lay down some strategies that should help us get started. An acronym that I found that I like is KNOWS. These letters stand for knowns, need to know, organize, work, and solution. Let's go into detail for each of these. First up, K, which stands for knowns. After you have read the entire problem carefully, take stock of the information given to you and any numbers that were provided. Understand what each of those numbers are associated with. It might help if you make a column of known values for yourself. Let's apply this to this example here. The circumference of a circle is 4 pi. What is the radius of the circle? Taking stock of our known values, we're given that the circumference of a circle is 4 pi. So that is our known here. And we can use the keyword is to make that an equal sign, like we learned from our keywords last time. Next up, N, which stands for need to know. Make a special note of what the question is asking for. In longer problems, this will help you keep your goal in mind and double check that what you calculated was what the question asked for. This is also when we want to define any variables for unknown quantities. And just like we have a column of knowns, we can have a column of unknowns. Let's apply this to our circumference example. We see what is the radius of a circle. So the question is asking for the radius, and that is our unknown here. We can go ahead and define a variable for this, and a good one to pick would be r. For this example, the radius is currently our only unknown, but if the problem had more, then we should try defining more variables here as well. Next, we've reached the O for organize. If we can, and haven't already done so, it's at this point we should draw a diagram based on our problem. We should go ahead and label the diagram with all our knowns and variables as well. It's at this point we also want to collect equations relevant to our knowns and unknowns. In more complex problems, our goal will be to try to get down to one equation with one unknown in it. Going back to our circle example here, while it's not crucial in this case, we can go ahead and draw a diagram of our circle. We will label the radius r, which we don't know, and we have that the circumference is equal to 4 pi. Next, we want to figure out what equation we want to use. The relevant equation for circumference is that the circumference is equal to pi times the diameter. Since we aren't given the diameter, we see that this would introduce another unknown or variable. So we've made another unknown d for the diameter. And on our diagram, it would be like this. Now, while this equation will relate the circumference and diameter, there's still no link to the radius, and that's what we're looking for. So we need another equation relating to diameter and hopefully radius. Recall that the diameter is twice the radius, or 2 times r. Now we have some links that get circumference to diameter and diameter to radius, so we should be able to get all this in one equation that relates the circumference to the radius. Here, how we do that is simple enough. Just substitute the value for diameter into our circumference equation. Doing that will give us that the circumference is equal to pi times 2r. We know c, and r is the unknown we are looking for. And everything else in this equation is just a number that we either know or can plug in. So we've gotten down to one equation with only one unknown, so we can move on to solving. And solving is exactly what we do for work. Once we have reached the point where we have one equation with only one unknown, we should be able to use our usual algebra to solve the equation. For our circle example, we will plug in the known value of the circumference, and we're going to solve for r. To solve for r, remember we want to get r by itself. To get rid of the 2 pi that is multiplying it, we must divide by 2 pi. When we do that, we will get just r on the right side equals just 2 on the left. So we get our radius is 2. So we've done some work, we've gotten a number, but are we done? That's exactly the question we ask at this stage S, which is for solution. It is at this point we think about the results we got and ask the questions, what does the number represent? Is this what the question asked for? Does it make sense? For our circle example, we got r equals 2. We know that the r represents the radius of a circle, and that is in fact what the question asked for. So we should be done, but does our answer make sense? Answering that question can depend on the context from the problem. In this case, we can at least make note that we were looking for a physical measurement. And for those, we want a positive value. If our work had gotten us a negative answer for the radius, we should take a moment to look back and check ourselves. This step of thinking about what your answer represents, and if that is what the question asked for, is more important than you might realize. It is incredibly easy to go through the calculation, get a number, and say that is your answer, when more often than not, there might be some steps left. In this problem, for example, maybe you had plugged in the circumference into the equation that had the diameter in it, and you got a number from that. You would want to realize that the number you got was actually the diameter. So you wouldn't want to stop there, you'd have to use that to get your radius, which is what the question had asked for. For one example to bring everything together, consider this word problem. The perimeter of a rectangle is 22 feet. Its length is 3 feet, less than twice the width. What are the rectangle's dimensions? We can go ahead and make our columns of knowns and unknowns. First off, our knowns. We are given that the perimeter of a rectangle is 22 feet. So that perimeter is or equals 22 feet. We also know the length is 3 feet less than twice the width. So those are our knowns, so let's think about our unknowns. The question is asking for the rectangle's dimensions. By dimensions, it means the length and the width. No values are given for those sides, so let's assign some variables. For the length, we'll call it L, and for the width, we'll call it W. Now to organize, let's draw our diagram of this rectangle. We will call this bottom side the length, and the right side the width. For a rectangle, the opposite sides are the same length, so the top side is also L, and the left side is also W. We can say the perimeter, or P, is going to be that 22 feet we were given. Now, let's try to get the relationship between the length and the width into an equation. The length is, so L equals 3 feet less than twice the width. So we have keywords twice for multiplication and less than for subtraction. What order should we do this in? Thinking about it with order of operations, we want to have 3 feet less than, parentheses, twice the width. So we want to have twice the width, and then take 3 away from that. Translating this into pure math now, this is what we get. And this is the value of the length. The length is 3 less than twice the width. To wrap up our organization, we still need an equation related to our perimeter, which relates to our unknowns. Well, the perimeter of a shape is just the sum of all the sides. Here we have 2 sides that are L and 2 sides that are W. We know the perimeter, but currently we have 2 unknowns, the L and the W. So in order to get down to one equation with one unknown, we will make use of the relationship between L and W and just substitute in what we have L to be. Plugging that in, we get 2 times, substituting this value for L, then plus 2W. Distributing this 2 will give us 4W minus 6 plus 2W. And putting it all together, we get 6W minus 6. We're down to one equation with only one unknown, the W. So let's substitute our value for the perimeter in and do the work. To get W by itself here, first we need to add 6 to both sides, giving us 28 equals 6W. Now we have to divide both of these sides by 6, and we'll get that W is equal to 28 over 6, which when simplified will give us 14 over 3. And our units of length are feet. Now let's think about our solution. We're thinking about the physical measurements of a rectangle, so we should expect a positive answer, which is what we got, so that's good. But what does this number represent? Well, it's the number for the width. Is that what the question asked for? We'll go back and read and see that they are asking for the dimensions of the rectangle. So not just the width, we also need the length. So we're not quite done after all. Now that we have the value for the width, we can plug in that value here to find out what the length was. We will get that the length is equal to 2 times that 14 over 3 minus 3. Doing this will give us 28 over 3 minus 3. We can think of 3 as 9 over 3. So subtracting those fractions will give us 19 over 3 for the length. And this is also our units of length, which is feet. So with that, we've gone over both some keywords and some strategies for word problems. While these kinds of problems can be the most difficult to grasp because of how different they all can be, hopefully we've provided some insight on how to get them started. Until next time.